So let me introduce, this is Mark Stefik, who got his PhD from Stanford and joined PARC in 1980. He was being a past lab manager at PARC. Yeah, you've been at PARC only 1 year. I always
almost the same time.
Almost, but I remember your hiring meeting. I mean, it's sort of interesting.
So you got to make the mistake rather than me.
Yeah, right. And he's now a research fellow. He has written a number of books on human creativity and has done a lot of work with Danny over the years. So you're going to see another facet of what Danny's done. Mark.
Thank you. Maybe you could stick around a second and we figure out how to use this Vista stuff. Open this double click. It turned out the sound in my computer didn't work, so I'm using Johann's. Danny? Okay. So it's great to be here, and it's great to be honoring things for Danny. I was asked at the beginning what would I talk about. Was there an abstract or something that would characterize what I would say? And one of the things I sent to Johann and Valeria was that everybody who knows Danny knows he's still a kid, especially in his sense of wonder and in his tenacity also for truth. So those are two things I think that really have shaped his character. I want to say he inspired my professional work, especially when he and Terry Winograd had done KRL. And I was working at Stanford, and part of my dissertation involved creating a knowledge representation language. And so KRL 0 and KRL 1 and so on were actually a big shaping influence at that time. I remember one of my co-graduate students at the time was Jonathan King, who, when he was reading over some drafts of my dissertation, I was doing some unifications between frame languages and object languages, for those of you who care about that. And I was saying that these were really almost the same thing. And Jonathan said, God, I'm glad somebody said it. These things all sound the same. The slots and instance variables are sort of very similar. And it turns out that going forward, those were the sorts of issues I ended up wrestling over with Danny. So I worked with Danny for about a decade, starting in 1980 and through about 1990 when I decided I desperately needed to write a textbook, and then ended up working on some digital rights things and so on, and our paths of interest diverted. So most of my talk today is going to be a trip back to 1980 through 1990 to look at some of the things that we did together. And start fix it. Okay. Is that better?
Testing?
Am I working now?
Yes.
Okay. I'll try not to fiddle. Okay, so there were really three projects that Danny and I were engaged together on. One of them was involved VLSI things, which I'll talk about first. Second one had to do with the loop system, and the third one had to do with collaboration software called the Collab. And I'm going to be telling some of the dirty truths about those projects today, so I hope you all can enjoy that. So let me start with the VLSI one, and say a little bit of who were the conspirators on that thing. So let me see how this opens up. So here we are, and I wish this picture was a little. Can I slide this over somehow? So maybe on you can help me, because this is going to keep coming up and it's taking up the whole screen, and that's not what I want. So could you make that small so I could still see the slides next to it? So just to explain who people are here, behind this, I guess I came to PARC after a period of work at Stanford on a thing called Mulgen. Ed Feigenbaum was here for a while. I don't know if he's still here. But there he is, way at the back. And one of the things that happened with Mulgen, since it was essentially designing experiments in genetics, was I sort of ran out of space on the computers. So coming to PARC was really a big deal because we had this new generation of computers, things called Dolphins and Dorados, and there was just a lot more space on them, and it made it possible to do the work. And so Lynn Conway was here, John Seeley Brown was here. I sort of was a member of two groups at the same time. And Lynn was sort of the force behind the VLSI credibility because she and Carver Mead had done all this work on starting this whole new design era. I thought it would be fun to come here and work on the next generation of really hard problems, designing VLSI as opposed to designing genetics. And Danny was a co-conspirator in that thing later, Sanjay Mittal. I don't know if he's here today, but I thought he was going to come, joined us a little bit in that work, and also drove this into more expert systems things. So there's a shot of us at that time. I want to show you a picture of Danny at that time, which is evidence of sort of who he was. Ta-da! Okay. Oh, I see this is going to be a recurring theme, how this thing slides over. So maybe the arrow button might work. Okay, but that's really not great. What do I have to do with this stupid thing?
Why does it?
I don't know why it does that.
Use the arrow on the bottom of the
Well,
presentation, which will go back and forth.
yeah, it might, except these are all in different folders. That's the thing. Sorry. Okay, well, this is Danny. Now, the next slide I want to show you is sort of living proof about, I think it's one of the few pictures I intended to put in here of myself. But it's actually photographic evidence that I came here when I was 14. Drag and drop it.
Click on the photo.
Oh, this is great. Stupid thing. Can I close this thing? I'm sorry to be so fuddly here. Well, let's do it. Okay, mark at 14. Okay, you can see I was a snazzy dresser at the time. And, okay. Well, see, there's no more here. Boy, I sure love Vista. Okay. Yeah, why don't you stay here and drive, and I'll just. Okay, so it's just because it's different. That's the only reason. Okay. So, okay, now let's go up a level. Okay, now, this is just a quick thing. I'll take a look at the docs here. This is where some of the secrets come in. So there's two things. Just look inside linked module. These are just two of the papers that we did at the same time. The thing I want to tell you about linked module abstraction, there's really two important things that come out of this VLSI project. Danny and I were working on models in one of the pods here of different kinds of VLSI circuits, and one of the different levels of abstraction for talking about them. We were trying to understand, in the way that Don Norman was characterizing how you understand systems and behavior, that you need to have some kind of model underneath them. And I want to reveal to you a rule from Danny, which I think has been a principle that's guided his research over the years. He says, if you want to build a system that's expected to act with intelligence, it must have a model. Now, I don't know that he would come out and say that, but you see it appearing in his work. There's consequences of saying you must have a model. I think if Ed Feigenbaum was here, was to take this to the next step, he said, of course, that model must be populated with knowledge, and we'd have that whole theme of knowledge-based systems and so on. For Danny, took a different path. Of course, it had to have something inside of it, but Danny was really more interested in the language. So to build a model, you need a language, which means every time you start a project with Danny, it's about one thing. But the first thing you know, we need a model, the model needs a language. The next thing you know, you're off building a language. Okay? And I think that maybe Burt Rayfield was the first person to discover this about Danny, because they're always writing these papers about AI languages over the years and stuff like that. And I certainly got to observe this thing in full action. Okay, well then, so to go on again about linked module abstraction. So one of the consequences of the VLSI project was we had to do loops, which is the next project I'm going to talk to you about all the language development. That was the language we had to build, and it was a big adventure, and that's the next story after this one. But a second thing came out of this whole thing of the VLSI project. So the dirty secret of the VLSI project was it really never happened. I mean, we did a few papers on it and stuff like that, but it actually opened up the next two projects. So this is the second paper I want to call out, one page from it on the VLSI project. And here we had these four different levels for describing things. Linked modules was a kind of a token-based architecture where you could see how circuits would run and the tokens would move. If we did designs for stacks, we'd have all these designs at this very high level of architecture about how stacks might work. Does the stuff work? Do links change? There's all these different models for it. And then you'd say, well, how do you actually implement that? Well, the next thing go down is this clocked models. And then, finally get down to layouts of things. We've got circuits being made at the bottom level. And each level of abstraction has its own issues, its own knowledge, its own rules of composition, and so on. And that actually is going to lead to the Colab project. And you say, why would that lead to the Colab project, which I'll describe next? Well, the thing was, Danny and I would be out there on these sofas, and we had a whiteboard about as big as this board here. And we'd say, well, I know how linked module abstraction should work. And we'd start drawing pictures in this thing, and the board would get full. And then over here, then we have to erase some. And we had to type stuff up. And we had these Dorado computers, which were as big as a refrigerator. So you had to like wheel a cart out here with this thing on it and type things up. And neither one of us liked typing things up. So, and this is sort of where the next project came from. We wanted to have, well, what if we could have a meeting room of some kind where we could all see this stuff and we had this sort of shared workspace and we could take our notes and so on it at the same time. I thought this was a great idea. And so he and I talked about doing that thing. PARC was going through a kind of a reorg at the time. And I remember we had a lab manager, not here anymore, who wasn't too much in favor of giving us budget for doing this thing. I told him if he wasn't going to give us budget for it, I was going to go down to the Goodwill store and come back with my circular saw and build the bloody things anyway. And the budgets came through. It was kind of an exciting time. But Danny was absolutely there. And I want to say he was kind of the prime architect in many ways for both these next two projects I want to tell you about. So you're not going to get any more about VLSI design here because I think it was actually mainly the launching pad for the next two projects. So see how this thing works? Going on to loops. Okay, so I seem to be getting the hang of this deal now. So first of all, the loops conspirators. Who are these guys? Okay, here they are. So we're getting, I'm not 14 anymore. The dress code hasn't improved any. And so Sanjay Middle, Danny, and I again, here's a picture, and we'll explain a little bit more what's going on the screen there. So that's the beginning of stuff here for, now how do I get this thing out of the way? Do here? Hey, that did it. Okay.
Recognize the chair and come to my office.
Okay, here's another picture of the conspirators. Somebody mentioned Alice's restaurant today. This is going to play an important role. I think we were trying to be knowledge engineers. There you can sort of see we have engineering kind of helmets on. And there's some kind of a strange logo, very mysterious and planetary, that's on the front of that. Okay, and we're at Alice's restaurant, which will need to be explained, I suppose. Okay, I don't like this. And, oh, one more. Last thing, we're also very conscious about the hidden messages and figures. Here we are with this truck in front of Alice's restaurant carrying books. What's this all about? Books. So Danny's got the selfish gene. I mean, I can tell from the colors. I've got sociobiology, which is Lynn Conway's influences behind all this thing. I can't remember what Sanjay's got there. I don't remember. But we're very much, so we have this knowledge systems area, but we're all thinking about memes and little ideas and how do they spread, and can expert systems be behind the spread of ideas. And there's a bunch of really strange things that aren't exactly in the field of AI at all, but we're being influenced by. Pat's got something. What's in the truck? Yes, this is going to come up. You're going to find all about these truck things, what this is all about. So, but this is the beginning of loops. And remember, this is all in service of building a model to do VLSI, right? You can see how far afield you can get with things when you're working with, which I think is actually part of the picture here about, there's this whole notion of passion and stuff like that. And there's a kind of an intellectual style. But let me get on to this thing. Anyway, we invented this thing called loops, which is an object-oriented language. It was sitting on top of interlisp. These machines were becoming available in the world. These were the Lisp machines. They're also the symbolic sort of style Lisp machines. And we had invented this language that had a lot of aspects of small talk and had a lot of aspects of KRL to some extent, probably closer to small talk. It's more of an object language, so it's simpler. Well, if you've got a language and you want people to use it, you should be teaching about it, right? So the next thing you know, we're running courses. So here's a first shot, Danny and Sanjay. Danny doing this business of, do you know why these things keep getting big? Like this. Okay, I can just go through these things. Okay, here's that weird logo. Okay, so the idea behind this thing, we said multi-paradigm language. So we'd been using interlisp. We'd added to this thing something called objects. And that's, well, I got through these two different ways of looking about things. There's functions and these objects with these methods and things. Was that the end of the story? Well, then the language itself grew to have a thing called knowledge bases, which is sort of in the middle. A rule language, because after all, this was expert systems, and if you didn't have rules, you probably weren't in the game. So we had a kind of a rule language. And there's this thing called active values, which were these objects. Basically, it was a way of saying if you've got an object and it's got like a property on something, anything which changes that thing could trigger a procedure. We thought that was really cool, because we could then have like gauges and things that would show when programs are reasoning. You could get these little This gives you basically a technique for monitoring what the system is doing. So here's Danny teaching, so to sort of show he's gotten excited. We've built this thing. I think the code had somewhere between 60 and 80,000 lines of code in it. It was actually fairly large. Sanjay had developed a system for running it through its paces, so we could tell when we changed the system whether it would still be okay and running and so on. We were looking for people to build expert systems in it. Here's part of the class. I'm not sure if this is the first class at PARC or another one. I actually found lists of all the people who took these courses at that time, and I was surprised going back over those things that there were people here from just industries everywhere. There were people from those 3-letter government agencies that people here have had to do more business with in the recent past. Here's another picture from the class. I see Dick Duda here, Sanjay, Alan Bell, Phil Gehring. Probably lots of people are sort of like, just can't see in focus or who they all were, but every time we ran the class, we would take over portions of the building. We'd give everybody, every 2 students would go off and learn stuff in the language and come to our lectures. And then there's this thing called the competition. So now this sort of story about what's the thing with the trucks is going to start coming out. What's this whole truck thing? Well, these are the gauges that could, like if you had a variable in your program, you could open one of these gauges, stick it on a variable, and you could watch it change as the program ran. That turned out to be great for simulation. Okay, trucking world. We knew that people had to have something to be motivating and exciting for the course. What better thing to do than have a game? So we invented a video game. It was called Truckin'. It was kind of like Monopoly in that there would be this, but the way the video game worked was you didn't play the game. You wrote the player of the game. So you would program a little truck, and the truck had to live in this little world. And as it drove around this world, it could run out of gas. It could encounter bandits and have everything stolen. It could buy stuff at one location, travel along, and sell it at another location. The idea was to sort of make a profit, enough to pay for gas, and to unload your stuff if you had bandits. And suddenly you had all these strategies that were coming up. You could sort of see where this thing about ecosystems and stuff like that was coming into our thinking. It was just loads of fun to watch these people write these programs. And so in the course, we'd give people these starting players, and they would modify them to make them more strategic and compete better. And you'd sort of see how it would be if you had too many programs that had exactly the same strategy. They'd be competing for exactly the same resources, and they'd run out of them. So it was just great fun. Of course, the reason for this whole thing was so that they could learn how to program in the language, and our reason supposedly was so we could have a language to do VLSI. You've noticed that VLSI has been forgotten by right now. We're off building video games, and people are playing them, and they're having fun with it. And here's a picture of the trucking board as it appeared in action at that time. So I remember that I wrote the thing that made the little trucks start up and speed and slow down and stuff like that to make them look sort of realistic as they popped along the board. And here you see a bunch of gauges. So this was called the knowledge competition, and this is the last thing that happened in the course. So you'd take the course from us, and in the course, by the 7th day, we'd say, now it's time for the knowledge competition. And everybody's truck would get loaded onto the same machine. And then we'd start the thing up. And everybody, so here we have Clyde's truck. Oh, Bonnie and Clyde, they were the bandits. And they could rob you. Okay, and here's Sanjay has a truck here. This must be some kind of a demo thing. And this little business here is a little rule that came up saying, if your goal is to sit tight, and blah, blah, blah. So anyway, you could get traces back, and you could see which rules triggered other rules and stuff like that. And there's this whole business of trying to program your players to perform. Well, I think maybe this is a good point to show you a movie of one of our knowledge competitions. So I'd like to close this and find a movie. Okay, truckin'. Let's make this a little bigger. And so this, I'm not sure if this was our first course or a second course or what it is. So this is about maybe 3 or 4 minutes. And you can see, these are the students taking the class. They're getting into the competition. The camera is rolling, and they're supposed to explain what their trucks are going to do. And we'll see a little excerpt of the competition and how this thing played out. So this is the mid-'80s at this point.
Our player was a visualization of Peddler.
It also cleaned up the algorithm that it used for buying gasoline. So it's not quite as compulsive as the original Peddler was for buying gas. We also try to avoid bandits.
We adopted an extremely promiscuous strategy towards buying and selling. If ever we were somewhere where we could buy something, we bought it if we possibly could without regard to whether it was perishable, breakable, or whether we, we just bought whenever we had room and we sold whenever we were somewhere where we could sell.
Yeah. Okay, there's the game board for the competition. Right. Anyone doesn't like it?
I forgot to mention one little thing. How do you win? You win by being the truck closest to Alice's restaurant at the end. Okay, if you can park at Alice's, if there's more than one that parks at Alice's and there's 2 parking places, I think that was the one that won. So these guys have got to go around buying and selling, avoiding bandits. If they're carrying perishable goods, they can break if you go over the rough road. There's all this stuff, right? So here we go. Let me start it up again. So hence the truck at Alice's, if you're to sort of tie back to his first picture.
You can tell, really. Is there any place we can sell our gold?
Yeah, Free Palace. Luxury goods.
But how come we only moved one step?
Because we couldn't make it over to Free Palace in that same move, so we choose the best.
But we didn't.
Yeah, we did. We bought books, I think.
Did we? No.
Uh-oh.
The bug.
No, we're going to have to wait.
Yeah, we don't have room to buy anything, we shouldn't stop.
Gas keeps getting replenished, but all commodities are going to get bought up.
And then we're going to see how many rules handle that situation.
That's right. Well,
Acme would fall in his head.
we're about to buy it.
What are you about to buy?
We're going back and forth between 2 empty gas stations.
Well, if you wait a while, they get refilled.
Coming down to the wire.
The lowest score at the end.
Bonnie sitting here.
Chris, where's Louis?
Oh, Louis got robbed!
Number 1 is Lucky Louis, 541,000. And number 2 is Technology at 343,000. And Turtle is number 3 at 189,000.
Oh, we're going to get Dirty Dance, no problem.
Let's see. What's the gas situation?
We'll get gas next time.
Tech is short on gas right now.
Right next to Dirty Dance.
Lucky Louis is sitting on gas. One way! Turtle on way! Well, folks, Technology seems to be in trouble.
We're just making it interesting.
Well, don't make it too interesting. Same time. Okay. Turtle's in the lead. 558. Okay. We made 50,000. Turtle is the winner. Cheer for the turtle.
Danny, do you remember who wrote the turtle? Was that Technology? I don't remember who it was. Was it Norton Greenfield, maybe? I don't remember. So these things tended to generate a fair bit of excitement across PARC. When we're having a knowledge competition, I think we ran the course at least 4 times. At least that's all the records I have for this thing. People would sort of come in the hallways, would get sort of full, and you'd sort of see these guys lining up and a certain air of excitement of all the stuff that's going on.
What's most well-known win is with Dave Patterson and John Osterhout, who came down and took the course.
That's right.
And stayed overnight at our place and kept programming all night in order to win.
Well, so the courses, after running at PARC, we began to see that this was taking off. We'd done a article for the AI magazine. It was sort of the cover story with this big picture of trucking and people standing in front of it and stuff like that. There's a certain amount of buzz starting up. We couldn't turn our research lives into just teaching courses on trucking and stuff like that. So the next thing we did is we offered a course at Leesburg, which is a Xerox training facility, and invited more people and got other people to sort of take over the teaching of this course and let it become part of the sort of AI product. Here's the first time we were teaching there. I see Dan Russell is showing up here, who's going to play a role in some other things later on, and Gaetano Borriello and Sanjay teaching the course there. Here's Danny the coach, helping somebody. So part of the idea here was to understand, not only to help people understand the language, but we had copious notes every day. What went wrong? What were the misunderstandings? Was it how we taught it? Was there a bug in the language? So the language and stuff is getting sort of improved at every iteration of doing that. And then as we were sort of looking forward from, well, so what? You did loops, you did trucking and stuff like that. A couple of things where this went, kind of looking at the historical nature of it. Loops later became a thing called common loops, which got merged with a thing called flavors, which then became the common Lisp object standard. So this whole thing, and remember we were doing VLSI research, right? So you watch this whole thing to evolve from trucking to courses and all that stuff. And okay, so let me try to kill this off again and go to the next set of pictures. Oops, it'll be here. Let's see, how do I go? How do I go? Oh, up here. Oh, there we go. Okay, the Knowledge Competition Rogues Gallery. So these are just pictures of people who sort of won at different times and stuff like that. So here's just another blow-up of the truck and screen. So you probably got the sense of this already. The trucks run along the roads, and these are the names of the places you could stop, and this would tell you the buying and selling prices of stuff, and there's gas stations. And so it was actually a pretty complicated world. So, so in a sense, people really had to write during that week a little mini expert system to survive this thing and play the game. Okay, and
Mark, can I interrupt you?
yes.
You never answered his question of what's in the truck.
Goods. So there's eggs, and there's diamonds, and there's furniture, and there's all these different things.
No, with the big truck.
The big, it's an empty truck. You know, we just borrowed it. we're just going.
Description of the game of trucking.
Yeah. Oh, you remember where the truck was parked there? It was in front of Alice's restaurant. So we're making a trucking movie to publicize the whole thing, and we just drove up there and got our pictures taken in front of Alice's with a silly truck and our knowledge engineers hats on. It's just all goofy.
So with that answer, you want us to believe there was something inside loops.
Well, of course not. We were trying to do the loop. Well, the loops. I guess I'll get to the scientific contributions of this thing. I was trying to give you a sense of the fun and the spirit of the time.
That was a joke. You don't really have to.
You asked for it. Okay. This is just a little. Well, one of the things about loops, of course, was interactive, and here you see this sort of multiple inheritance hierarchy, and the people taking the course were, buying fruits and vegetables and hammers and art supplies or whatever they were doing. Here's another shot of people at the course. Here is the winning place where this is, I'm pointing on the screen here. This is Patterson and Osterhout with Lynn Conway, and they put on their Peterbilt hat, and I don't know what kind of a thing that was for the course. I guess they won. That's pretty cool. Here's Terry, actually, who spoke to us this morning, and I see Richard Burton back there and a bunch of other folks. Remember, there's Peter Denning in the picture there. So there were luminaries from all over the place who were coming to take these courses. See what's this truck all about? What's this loops thing all about? I threatened Alan Bell. I had a picture of him. If he's here, you can find it here. Right. But I don't know if Alan's in the hall. The making of Truckin' the movie. This photo has never before been seen, as far as I know. I just found it. I have this pile of photos. So there we were, on the hill, getting ready for the silly movie about Alice's restaurant.
Notice the price of gasoline.
Yeah, okay. 36 cents.
Oh my God.
There we are. More photographic evidence. I was 14. Okay. So, I hope you guys are enjoying this. This is kind of like a trip down memory lane for me going through this whole thing. Okay, that was the Rogues Gallery, and then we go to AAAI. Okay, so here we go. Here's Danny manning the booth on one of the computers at AAAI, getting ready to do stuff. And I mean, the thing about working with Danny, I should say something about this, and this is a theme which comes up over and over again. You could have two people. Well, I'll tell you a story that he said was something he learned from Terry. And I suspect that this might be true about people who collaborate closely when they're working really hard on ideas. He said, if you're working with somebody and you've got almost nothing in common, there's very little to say. And if you're in total agreement, there's actually very little to say, we just agree. But if you're this far apart, the energy shoots way up to get that other person to move that last little bit to be on the same page that you are. The thing I want to say about working with, so we had lots of very energetic conversations. And Danny was a better lisper than I was. So, but I'd built systems before and stuff like that. So we had a little bit of competition, but mainly he was just really faster. And but one of the great things about the design questions that came up, and this is something which we developed out of trust for each other, and something I just want to speak to in terms of how research works when it's going really well, is that you could have a discussion and have opposite sides and argue your position. And then we would get to a point, as I say, because we're very close and it's all heated and whizzing up and stuff like that, one of us would say, okay, trade sides. Okay, this is a marvelous thing to do because it forces you to not be personalized on the position of argument about what you think is true. It says you're just arguing on the merits of the case. So trading sides gives people a chance to first verify that they understand the other person's point of view, and then also to articulate it. It also removes the winning and losing aspect of whatever you're trying to do in the design. So together you have a joint exercise then of coming up with the best understanding and the best possible design. And this is something that came out of our working together, and then as Sanjay joined the group and the group got a little bit larger, it became part of the group culture. But I remember one time that Austin Henderson, who was not a member of our group at that time, came to one of our meetings to propose and talk about something. He said, I felt like I was dropping into a pool of sharks. And the thing that had happened was we had such a high level of trust that we could trade positions and argue and shoot and stuff like that. It was a very, very efficient kind of way of driving the ideas forward. And it's exciting if you're working with really smart people and sort of able to sort of rev up the speed at which meetings can happen, because you can take shortcuts. You know you're not bruising egos too much because you've already developed this elan of a team which is trusts each other a lot, loves the ideas, and is just searching for the best possible solutions. So I wanted to explain that that's one of the things about working with Danny. My title, what does DGB stand for? And everybody's probably looking for some clever, the D stands for the, what I really meant, what DGB stands for is Danny stands for stuff like this, about the way of doing research. So.
Before you leave that picture, Mark, what is that pink thing?
Pink thing? We're into the fine qualities of dress code here again, yes. Okay, here's Larry Mesenter manning the booth again. And and here's the knowledge competition at AAAI. So we staged one of these events in the trade show there, and we had these little trucks we'd give away to the winner, little model trucks. Wow, these were heady days for AAAI, and I guess I'm being the announcer there. Martin Kay, I don't know if he's here today, Martin Kay wrote this marvelous program that was another client on this distributed thing because the players could be running on different machines. Martin wrote a program which would look at the state of the board and be like the track announcer. And now there's Lucky Louie, whatever it was. And I think the reason I was holding the microphone here is because his program broke down at a critical moment, I think, at AAAI, but mostly it worked pretty well. And so it would look at what's going on and generate a sentence, and we had purchased this, text synthesizer. So it sounded like your Swedish uncle talking about what's happening in the game. I know that was the state of the art then, but it was fun because then you had the people who wrote the games, and then the computer was giving the sort of track announcement thing. It was just a lot of fun. So let's see, are there any more in here? Oh, and this was the sort of winner circles at the end of the AAAI, and you see Martin there from the writer, Norton Greenfield, I think. Oops, sorry. Norton, I think, was a previous winner. And here's Danny and Lynn, and I don't remember who this is. Anybody, Danny, do you know? I think she was one of the winners with, and I keep thinking the name is Polyoki, but I don't remember if that's it or not. I didn't look it up in time here, but that was the contest at AAAI. I think
They're actually selling this machine.
Oh, right, of course. Yes, there was a purpose to this thing. We weren't doing deal sign, right? Right. Okay. Now let's go back and see. I had more to say about this thing. Loops AAA documents. Okay. Here, I have the list of people. I won't take you through that. Knowledge programming. So, just to say a couple of things about this thing. I'm not going to pull up the papers behind this thing. I'm just looking at the titles here. The knowledge programming and loops was a paper we did together on that sort of opened this whole idea, explained the knowledge competition, the course, and the basics of the language. The loops manual was just a very, kind of an augmentation of how to use the thing. Access-oriented programming was a paper that Danny and I and Ken Kahn did together, and it was really an interesting paper. I think I had started the paper, and then of course with Danny got it debugged. And then we said, where are we going to send this thing? And there was a conference in Hawaii. And for reasons unfathomable to me right now, I couldn't go to Hawaii. I mean, what was wrong? I don't know. Ken Kahn said he could go to Hawaii. So next thing we know, he was an author in the paper. Ken's off in Hawaii. Danny and I are off doing miserable things. I don't know what we were doing. We couldn't go to Hawaii. Ken goes to Hawaii, and the thing wins the best paper award. Okay, so there you go. Okay, so that was a paper about this whole business about being able to, on active values, where you could have programmatic things that would happen when somebody put or get a value. And I guess there were attached procedure kinds of ideas long before that. These things could be nested. It had some nice properties for languages. Well, then the Common Loops paper comes out. There is where this stuff is moving its way into a standard for Common Lisp. And then finally, Danny and I do a Bert Rayfield deal, because Danny and Bert wrote earlier papers about the structure of the state of the art in languages. And Danny and I did an article for Science, actually, on AI languages. So that's Now remember, this is VLSI, right? You had to have a model to have a model, to have a language, right? And then the other thing that happened, as you may recall, was the whiteboard got too full, right? So the other project that we really did, instead of doing VLSI design, is next. Okay, and that's the CoLab project. And I always have some, when Don Norman said, who had this really popular paper, you know, people ask me, from what I do as my career, say, well, didn't you used to be in AI? You know, and other people say, well, didn't you used to be in programming language design? Or didn't you, and not sense making, we're doing a workshop in sense making at KIND next week, or digital rights management. So, I mean, it was that way, it's been that way for me, and I think it's been that way for Danny in his whole career, and certainly my time from the 1980s to 1990 with Danny was one of moving through fields. And your friends sometimes wonder, what are you doing working in that thing? Because it doesn't sound like you're supposed to be in my field, you're supposed to be doing this thing, and we've gone off and done something else that was interesting. So about the CoLab project, first of all, who were the conspirators on this one? And here's a picture of the CoLab as it was then. And here you'll see it's me at the thing called the Electern, which will come up in a little bit. Here's Danny. And then Greg Foster was a grad student at Berkeley who came to work with us, and this became his dissertation. We were building this CoLab around him. And so he did a lot of the studies, and some of the tools were really mainly his. So, the conspirators, what were the big ideas? Okay, the first thing I'm going to say, some of you know that I wrote a book with my wife a year or two ago called Breakthrough. It's trying to explain in a serious way about where do ideas come from, and how do you organize laboratories or research organizations to do things well. So I'm going to show you, the inside secret about where the ideas came from for the CoLab, just in case there's any doubt. Okay. Okay. And taking it a little bit further. Okay. So all this stuff was sort of going on at that time. So what is this? We had done some design work. We were thinking. So this is, I think, like mid '80s. We had this notion called a live board, which later became a company here and went out and tried to do that. We were also thinking about live pads, which was. It's sort of I think is thinking about the same sort of thing as the what do you call these computers? We have you flip the screen, the tablet PCs. Then we had a live table, and of course, there's been a ton of research on people building interactive tables of one kind or another. Ours, so we were envisioning it at that time. Then, but behind this thing was a thing we called portable ideas. And so back to this book about memes and things like that, we were imagining that if you had these kinds of devices, and I suppose it's happening anyway, but somehow this seemed like one of the driving metaphors for what we were thinking about. Here's some guy in his office, he's working through some ideas. It's somewhat felt, I always like running to the whiteboard, and that always worked with Danny, I think, because it's a public space. And the CoLab itself was trying to create a public space where your elbows don't get in the way. You got two people in front of a screen. How do you share that? So he's in his office writing on this thing, and later walks down the hall and shares it with some other people. Now the conversation moves forward so that you can see them talking about it here, and then later in the coffee room there's more stuff. So the idea was the whole place would be wired with these kinds of screens, and you could sort of pick up a conversation and join it later, and you'd be using these things. Tony's pointing at something here, I don't know. Steve Osborne drew this picture. That's right. So Steve was got involved with us at that time. Here we are again with James. Okay, so let me pop up. Big ideas, where they came from. Well, Stu was at my house recently for an evening, and said one of the things about working with us, and it certainly grew out of this, but it's really Danny and me, was building furniture, was what he was saying. What were you guys doing building furniture? So, God's confession, what else is going on here in the service of VLSI design? Okay, well, so if you're, if you want to build this room, they've got to have computers. Everybody just got a laptop, and they're the little flat screens and stuff like that. Of course, we had these Dorado things, and you couldn't possibly put the computer in the same room where you couldn't hear yourself think. And the monitors were big and fat. And so we imagined that, and we tried sitting down in a room across from each other with these monitors in front of us, and you can sort of see immediately what goes wrong. You can't see each other, so the monitor's got to go down. So it's got to be at an angle. That means the lights reflect in it. So you've got to do the lights different. You got to have a table. How do you get the level right? Well, there should be a motor that raises the monitor up and down. So we got into this thing because we actually wanted to use these rooms and to have meetings that really work and explore the idea. I mean, you know, we're trying to save time because we're too lazy to copy things off the board. Now, I'm put in mind of Don Norman's thing. We're walking down the street, we see a store is missing. I mean, don't these guys have any regulation on what they're doing? Yeah. But so I'm in San Francisco. Here's a picture of Steve Osborne. He's got this particle board version of this desk. The hole is where the monitor is going to come up and down from. What do you think about this, Mark? We've tried, you know, pentagon shapes and different things. Okay, so we're charging forward. Here's a full mock-up of it with a, you know, as the computer might appear. Okay, so part of it's building furniture. But then you may remember, going back to Star Trek, if you look at the early series, and maybe the later ones, I don't know, they're on the Enterprise, they're on the deck in the front, and there's this big screen at the front, a little thing going beep, 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 beep along the bottom like that, and you see the planets coming at you and the Klingons or whatever, right? Well, you can't have a meeting without having a big screen. It's got to feel like the presence of it. And we're all staring at this little thing. No, it's got to feel like you're in a big place. I needed to have a big screen. Well, how am I going to point in the screen? Now I want to walk up the screen and do something. I didn't know how to do that. And later I had this ultrasonic pen thing I invented, but before that, Danny and I wanted to do this. Video projectors had come out. They cost $70,000, but hey, this is PARC, right? So we could do stuff like that in those days. And but how am I going to get this to tell how you're using this board? So I'm off to the Skunk Works, which was a piece of things in part of East Rochester, and they built us a board here with it's a printer company. So there's this laser thing in the corner, you know, little lights, and so that when you touch the board, you intersect the light beams, and it figures out where your finger is, right? So then you got to do all this sort of timing stuff, and the mechanics of it, but you can sort of see how it worked. You know, there's the laser hitting your finger, and the reason it's a printer company is because the little wheel that spins around there was the same wheels that were used inside the lasers of our copiers to zip laser back and forth and illuminate stuff, right? So I mean, there was. Never mind. Okay, so then the thing gets built, and you know it's furniture, and it looked like a giant. There's the Star Trek thing. So and this is the room as it was constructed. Then there's the indirect lighting on the side, so that the light wouldn't shine on the screens. And there we are doing our thing there. And so we, you know, all this, so we wouldn't have to copy the stuff off the board. Okay, and we wanted to record how meetings worked, and so these hidden cameras on the side that we could do with. And if you wanted to stand at the front, there's this thing called the electern, the E-lectern. So like this is a lectern, and then it could go up and down. It had a keyboard on it and stuff like that. It's pretty cool. Another picture of the E-lectern. Okay, and then we also discovered that this furniture stuff that we were interested in, that, you know, this is one of these things, that the idea, you're going to have a meeting. So everybody's going to pick up their work and go to the collab, right? You know, and then the collab will start a meeting, and I'll talk to you about those meetings perhaps, because they just amplified the kinds of characteristics that Danny had for the way groups worked. But we also discovered that a lot of work happened outside the meeting room. So we built these little corner desks for that, and then it turned out that those were of course going to be in public places, so people could agree to come to the corner desk and do their joint work, which was just stupid. So then what we're going to do, was this just a complete design failure? And somebody wanted to have one of these things in their office. And as soon as they put it in their office, this team programming started happening. We said, oh, that's how you're supposed to do it. And so then we built a bunch more of them. And in fact, they're still all over on PARC. So there's just like, you know, at least a dozen of these things as old furniture from the 80s that were part of the collab project that got built. So I want to show you what is this collab stuff all about? And I've got a movie for you. And then I'll try to explain to you if there was anything here that deserved it being a best paper, because you're saying, now what field did you say you were in? What problem are you trying to solve? So here's a little movie about the collab from that time. And make it a little bigger. And maybe you could dim the lights a little bit when I start this thing, so people could see it. And I start it. So here you can sort of see the place in action. And then I'll try to explain to you what was interesting about it.
While extensions of single-user facilities are interesting, most of the collab project has been devoted to the exploration of software to support group work. The key idea is to provide a shared workspace for a group that appears on each person's workstation.
The first time we used collab, we weren't even sure it was going to work before, and we had never really used shared workspaces before. We were used to using personal workspaces, and it was terrifically productive to see other people's ideas popping up and being connected to what I was doing as I was doing it.
Here we see a shared workspace embedded in private workspaces. To understand a shared group workspace, think of a computerized blackboard, available to you and to everyone else from where you sit. The computerized blackboard makes it easy to rearrange items, to change or delete them, or even to recall something you accidentally erased. Such a system can also remember the entire workspace so it can be reconstituted for the next meeting. One problem with distributed shared workspaces occurs if you try to point your finger at the screen in front of you. No one else can see where you're pointing. The large black arrow appearing here is a telepointer, showing where someone else at another workstation is pointing in the shared workspace. To give you a better idea of how software can support a particular kind of meeting, let's focus for a few minutes on the meeting tool we use the most. We designed a tool called Cognoter to support small groups that are trying to organize some information for a paper or a talk. The way it works is they can put little pieces of information up on the screen. They can shove these things around, play around with it until they get a structure that they can use as an annotated outline that will serve as the basis for their paper or their talk. In the first part of a Cognoter session, the goal is to have people get ideas out of their heads and into the computer system. Everyone in the group has equal and immediate access to the shared workspace. They enter items, brief descriptions of their ideas.
Let me pause you for a second. When you look at this picture of the Colab screen, what's going on here, we're looking at one person's screen. And sometimes you see things popping up here. That's somebody else doing it on a different computer. So this is a shared workspace, was the basic idea. One of the things that we noticed about these meetings was how incredibly productive they were for things we didn't predict at the beginning. In ordinary meetings, when people are coming together, we take turns talking because the audio channel is inherently shared. We negotiate for when we can talk and when another person can talk and so on. And let's say we're talking through a series of topics. If you come to a topic and the conversation branches off this way and you still have more stuff to do, you really have to negotiate your way back to that point later on. The Colab changed all those constraints completely. If Danny was putting in some ideas on one thing and I thought they were wrong, I could skip over and type some of the things into it. And he could say, oh, good, and grab those ideas, so to speak, right from a piece of the screen visually and pull it into the part that he was working on and so on. If the meeting ended up working on, if there were multiple things to go forward on, we could fork the meeting while we were there. Some people work on one part, some people work on another part. They could have visible views on what other meetings were doing and then converge and come back later. One of the things that I felt was happening in these things, it took this sort of interpersonal collaboration things up a level. Things went faster because you didn't have to wait for your turn from the audio thing. You just type whenever you wanted to type and stuff was appearing on the screen just all the time as it went. So we got an awful lot done in a short period of time and everybody went away exhausted. So I think that was a win, but we certainly shortened the times of meetings, but they were really intense. And so the Beyond the Chalkboard paper was about this whole experience, the invention of what we called WYSIWYG. WYSIWYG was famous for what you see is what you get as a kind of standard for the way we all expect editors like Word and so on to work these days. WYSIWYG meant what you see is what I see, meaning we've got a shared public space in which we're doing things at the same time. So Danny was a major architect of a lot of this stuff. And in fact, the foundations of this thing go down into loops because the way we wrote these programs, these were running on multiple computers. We took the notion of method, which was a thing, of course, which describes how, it's like a function call in that kind of language. We call it a broadcast method. What that means is when somebody does something on their computer, the broadcast method ripples across the network and runs on the other computers at the same time. So it became an easy way to do parallel programming, if you will, or synchronized programming across multiple machines. It's a variant of RPC for those of you who are into the programming language designs of this. So there were all these connections between the language design. Remember, Loops was originally designed to be the model for VLSI, except that it got extended to support the collaboration so that we didn't have to write stuff down on the whiteboard, so we built this room. I mean, it's an amazing journey of all the stuff that we got into here. And
as soon as they think of them.
We'll hear the rest
Items
of it.
contributed by others appear on
here
your
you see it
screen,
running.
even as you enter an item of your own.
In the first part of Cognoter, we want the tool to stay out of the way as much as possible. We want it to be flexible and want to be as little delay as possible when people put their ideas down. And that way we expect it'll be much more useful.
To expand on the short idea phrases, longer pieces of text can be associated with them. In this multi-user system, everyone can see and manipulate the shared information. They can add or change items.
So I'm going to stop the movie here rather than going through all of it. So that we ended up developing a whole process for how to organize information in papers and things like that. And of course, since we're computer scientists, it had to be a graph, and there are all these, the usual transitivity It meant that it was a very easy way to think through pedagogically the order in which topics would be introduced and so on. I kind of missed the system. It was really a terrific thing, and I think it kind of juiced the way we were able to produce things during that period of time. So I'm going to go back to here and see if there's anything more I want to show you about pictures of Collab. How am I doing on time? Am I about out? I'm out. Okay, so let me just conclude by saying that there's a kind of intellectual style that came from this thing, which had to do with following your passions, had to do with having effective collaborations. There were ideas from these things. They cross fields. I'm not going to. There's obviously no time, and it's a little bit difficult to give you the intellectual bearings for why the cognitive science or the computer-supported work community thought this was an important paper, or why the language papers were thought to be important in another area. But there was a unified style of exploration, the desire to articulate the best you can as a group, the true meaning underneath, the true importance of what you're doing, and the best designs. So recently. So Danny and I really haven't worked together much for a long time, and recently we're sort of within elbow range again because I'm working on projects which are bumping into natural language processing. We're doing a thing which will probably be a PARC spin-out. That's what we're working towards. And I'm finding myself engaging with Danny again, and it's a great pleasure to return to that space. And so that's the conclusion of what I wanted to say here. The reason there's so many pictures I don't know is I think that 1980 to 1990 was just a highly documented period of work we did together. Obviously, I had a lot of fun with it, and I wish everybody who works with Danny great success with him going forward. Thank you.
Thank you. Thank you. We'll have a break now. I think there's cookies and drinks outside, and we'll be back here at 4 o'clock.